we'll come back and talk about this later. I'm going to say if you were here yesterday, then you already know about that, and hopefully you've already subscribed and you're an awesome person. But we'll come back and talk about that later. What we'll talk about first, Purdue Science. That's all I should have typed in, right? Yeah, Purdue College of Science. I'm going to do it right here, Purdue College of Science. Then all that matters in my world is the outreach, because that's where all the free stuff the teachers are. Bill likes going to the outreach home. Like I said, that's why he always does it. Then he scrolls to the bottom. But to me, that's well. If you do that, you can see my dog Leah. Oh wait, you're gonna see him in a minute. Hold on. But I'm kind of like a short and fast. I just jump to the teacher stuff. All right. So today, as I scroll down through here, you can see, of course, this is the workshop we're actually teaching now. Severe Science has stuff on it. Globe, we have like a host of the Globe professional development since before COVID.
Right.
So that we might offer it again, I don't know. In the open conference, that's the computer, all kinds of stuff for computer science. We spent several months putting that together, like mercy. But then the campus programs, that's just, we do POPs, hands-on Purdue, and that's where we have now a lab that the three of us actually host groups on campus. So if you're from around here, you can check that out. And our AP Fridays is basically very similar to that. It's just for AP class. But now let's drop down to our e-learning resources. You'll see this top one, middle and high school labs and resources. It's the same as the lesson plan, middle and high school lab resources. If you're not sure which one to click, they go to the same place. So let's click there. All right. That's just the easiest way for me to remember to get here. So Sarah will probably show you another way to get to this particular lab later, but this is just the easiest for me. On this, we're trying to put together, well, more than trying, we are putting together. And we have a bunch of these in the making. We have teachers that we're collaborating with who's helping us design and put a bunch more virtual labs up. So we'll have another at least 5, 6 probably before the end of the summer, I'm guessing. And this first one is just a resource page. If you're doing anything with radio activity and half-life, there's lessons, videos, there's interviews, there's all kinds of stuff, background information on there. The second one, or under virtual labs, now let's jump down to that. Classifying matter, that was yesterday's first one. That's what Sarah taught in the very first one. And then Sarah's afternoon yesterday was the photosynthesis we talked about. And so if you're in that, I know some people said, well, where will you see the updates? Once we actually get the stuff in and we run that lab and get those short video clips and stuff, this is where I'll put them on that page. And so it's an easy way to find all these sessions we're doing, right? And today we're going to do investigation of Earth systems. I went ahead and put up the link to the page. Did that last night, and so it'd be nice and easy to get there. Now I want to start off kind of with phenomena. And so we put this short. Now I did screw up the very end of this, and you'll see where. I'm going to go ahead and just hit that, and we're going to watch that first, and then we'll continue down the page. Okay, maybe I should have waited before I did that. Oh, there's a port on this? I should have moved that. Good. All right. Basically, it's boring. And so it just talks about...
It's not boring.
Well, I've seen it 1,000 times, and I was there. So basically, we just talk about, hey, we wonder why a car heats up and how much for a short trip will it heat up. And so then we have this going at like, 1,000%. It's 20 minutes. You see the seconds down at the bottom. And so, and then at the very end, we see that there's a rise of 59 degrees Fahrenheit in 20 minutes in the car. And then it just stops. And where I screwed up is this is only there for like 2 seconds. And then it's gone. And so I should have left that there a little longer. And so if you do show this to the class as an engagement piece, you might kind of pause that so they can see that. And Sarah and I argued a little bit about it because I want to say not scolded, tormented maybe. There's another word, I just can't think of it. Shamed, maybe?
Ridiculed.
Ridiculed, all of these, which is a daily thing for me. But this is like how hot the car gets the rest. Yes, that's exactly what happened. We took my car up to the parking garage on a sunny day. We put a thermometer right here in the window. We closed the doors. We recorded our veneer. And we used the wireless veneer thermometer. And so we just hung out from the mirror, and it's hot. I didn't see it.
Which part of the car?
Inside. Inside. We're measuring the inside. I don't know what the temperature was outside the car. We were just measuring the inside just as a quick engagement piece. And, but she, ridiculed because I wanted to use Fahrenheit. And we argued back and forth about that, but I won because I edited video. Yes, I always do Celsius when I'm doing things in the class, but the kids don't understand what that meant. And I just wanted the engagement piece to be more on their level. And so if you like it or not, I don't know. We'll put the data up in both Fahrenheit and Celsius because Sarah recorded it with the veneer graphical analysis. So we'll have the data for both if someone wants to use the data for something. But that's the engagement piece, kind of for a full unit. But then what I originally had was just the fact that my puppy Leo, he loves to go with us. And
you were right.
See?
Yeah.
We have that recorded, right?
That will be deleted. I'm joking.
Is there a computer program comes with that thermometer? Oh, let's explain that real fast. The veneer thermometers, I know in years past we've given these away as part of our kits, but we didn't this year. And but the nice part of what we really like about these is they're wireless, and the graphical analysis, that's the program, right? Yeah. You could use it as an app on your phone, on your iPad. We Bluetooth to a computer, and here you can see we're running off an iPad. But and we run it off the computer most of the time in our lab. We run it off the computers. And it's nice. If you're doing a demo thing, that's great. If you have a grant to get these for the classroom, it's Veneer. Veneer Go Direct. Someone asked the name of it. Veneer Go Direct. You want to type that in the chat? And someone's ahead of us. We have a lot of their stuff. I'm not endorsing one over the other, but we have a lot of their stuff, and we use it for our labs. And Purdue Chemistry uses it for all of their labs, the veneer stuff. And so we felt we made a good choice years ago. And so yeah, it's a little pricey. They're a lot, which we'll discuss here. Some less expensive ways of doing some things. It's like people who got the kit. I used a grill thermometer for some of our demos, and you could have done that here just as easy. But you would have had to record the data instead of sticking. All right, moving on to Leo, the puppy. He's inappropriately named. I called him Leonidas, King of Spartans, and he's the biggest weenie dog we've ever had. But he loves to go. Leo loves to go with us for the car. But in the summer, we can't always take him with us. We're doing a quick trip running in somewhere. It just gets too hot for Leo. And so the question is, why does the car get so hot setting in the sun? Then why does it get hotter in the summer than in the winter? Was my engagement question. And so, and that's why we made a little video, a 20-minute video, because if you're running into the store, oftentimes it takes, by the time you get through the line and stuff, it can easily take 20 minutes. And as we can see, 59 degrees Fahrenheit increase in temperature, that's pretty dangerous for anything. And we see it with the video, we can actually look and you see how fast it went up. And we'll put that data up there later. I lost, we had trouble finding the data. We just started around and get that.
Is Leo an Aussie?
He's half. Yeah, yes, half Aussie, half. What was the other thing? Oh, I'd have to ask.
Dog.
Yeah, he's just a dumb dog. Yes, half something else. I can't remember the other thing. But they're like, oh, that's a quiet and smart breed. Well, apparently two smarts cancel out. Give you the dumb. But and so I like doing with the kids. I like engaging them and really getting them thinking. So I like doing like word webs. And so, and with this one, I mean, we had a bunch of AP classes, and I didn't have one I was doing this lesson on. And so I thought, what's the closest thing I have to middle school level? Oh, that'd be my friends on Facebook. And so, so I went and asked them simply, you know, what do you think of when you think of a car heating up? And so I got everything from stories about crowns melting and chocolates melting. Someone asked me if you could cook an egg on a dash. Could it break my windows? Yes, it could, by the way. That story later. You know, someone's Pepsi exploded in there. Should have been drinking Coke. It wouldn't happen. It still happened. But it's in other questions, you know, what is the car heating up? How's heat getting into the car? Where does heat come from? And do window shade help? That'd be a good thing to investigate. And someone talked about their gummies. Hey, wait, I think that was actually Kim. I think it was Kim McKay who put that on there.
Interesting enough, we were talking earlier, one of the teachers is from Phoenix. When I moved to Phoenix and started teaching, the one thing they were selling nonstop were these little, you roll down your window a little bit, and then you would put this thing on there, and then you roll your window back up, and it had a fan that would pull air out of your,
circulate.
It would bring air out of your car. So it didn't keep, but it drastically allowed it to not get as hot inside there.
Well, we used to, when my son was in Scouts, we would, for the county fair, we would run a parking lot.
Yeah.
And that one year, I think we had 4 or 5 cars where their windows exploded because of the heat.
Yeah. And someone just said there's a really cool TikToker from Arizona who tests cooking, melting different things in a car. Might be a cool connection for middle school.
Oh, there you go. My wife totally wouldn't let me do that. And so I like doing a word web, and I like just having them start putting their ideas on it. I always do these on the board when I do lessons. And it made
cookies. Oh, jeez.
We tried out. I could handle the smell of cookies
In your car?
Yeah. I was just thinking like the eggs and stuff. That'd be.
It's supposed to get to 90 later this week, I think. Maybe we should try to make cookies in your car.
I'm not against.
Or cake.
It'd be harder to make a cake, I think. I'm not a baker though. My wife and daughter are, so I don't have to. 114 there.
Wow.
Oh, hot dang. All right, so to jump to the unit, that's my engagement, a couple of engagement pieces for this particular unit. And as with all of our stuff, mix and match to what suits you best. But the unit, I start with waves. Let's start with where the energy came from and talk about the sun, right? And the sun. So then we can talk about waves. We can go into all the different solar ovens. I've done that before too with the kids. But we can go through all the different aspects that we need to talk about in waves, because in our standards we have a lot with waves. Now I decided not to keep, and this is, I stole it off of NASA. I gave them credit. You can click it and have a big one if you want to put up on your thing. And I just did that so you didn't have to keep looking for stuff. I need to fix that. But I thought, for a couple years in a row, is our thing not on? Or am I not plugged in? Plugged it in the computer. My laptop is getting ready to die on me here. But for like 2 years in a row, Sarah and I did videos on how to use the spring. And I really like these little plastic springs. I have the metal ones. They get bent out of shape a little too fast. But these, take that. I like these because, what are you doing?
I'm showing this.
Oh, I like these because you can go right through the middle of the class and you can do quite easily. And you can see there the wavelength. Students get nervous, and that's kind of my thing. And I scare people. And so, what I love about this is, and it's in the other videos, but if you get these, you can see where those nodes are. You can talk about wavelength, talk about your crest. All those things are right there. And what I love about it is you can talk about the energy. Now, I'm not using much energy here. Now, to get that higher wavelength, you've got to put a lot more energy in there. And so, I like that.
I'm tired for you.
You out of breath. You're just holding one in. And so I love using these thinner springs for that. I know I used to use a Slinky 100 years ago, and stuff, and I still have like a whole tub full of Slinkies. And but I really like this. Now, some people aren't as hazardous is not the right word. Some people are more reserved than I am. Most people are more reserved than I am. And so a lot of my teachers, they will actually put this on the floor and just go across this way on the floor. And yes, it works fine. I said maybe your whole class, well, actually, they're long enough. Your whole class probably could. And so, but you can do that on the floor, and that's fine. I just like doing it right through the middle of the class because it's, I don't know, I'm just that guy, you know. And so I like these. Here, thank you. All right, but when I talked about the videos, we did for 2 years in a row. We did videos on these, and so here's a link to the one we did last year, where we're explaining how to use these. There's the metal one, blah blah blah, and so there's that. And then below that is the 2020 pressure development that we did. I did not catch that word or that question. And these links are straight in here.
Was that a rope? Was that again a rope?
This was a spring. You could do these with a rope. If you do it especially on the thing. Now, the reason I like the spring is, hey, fire that up. The reason I like the spring is because we teach earthquakes. If you're teaching earthquakes, the spring lets you do your compression wave. Here, Bill, let's do the compression wave. Thanks for putting that back in the bag.
So Marcy asked me for the list of all the supplies.
We'll put up.
No, I said for Marcy, email me and I'll send it to her.
Can we put it on where we got things? Are we allowed to do that, or is it too everything? Well, so the compression, you can answer my question in a second. The compression, all you do is pull some with these, and you could see that going back and forth. Yeah, I love that. I love that you could see that. So if you're teaching earthquakes and compression waves, you can see that, and you can see that wave reflecting. And so it's really nice. It's actually, you can see the reflectance, and these are really light, so you can have a smaller student. Sometimes with the metal spring, I'll pick a smaller student and make them hold it up here, and it's a little harder for them, and it actually moves them because they don't expect it the first time. And so we talk about transferring energy. And so here, if we're doing the compression wave, I'm transferring energy with using the spring as a medium from Bill, and it's bouncing off Bill, but some goes into, absorbed by Bill, right? And the rest is reflected back and forth. It gets shorter and shorter because of the absorb. All right, now you can have that back. I'm done with that. All right, I'm going to talk too fast again. Anybody yell about that?
So that all the materials that we're talking about, yes, were sent in the kits. And I sent an email out to everybody who was originally on the sign up where they signed up for the free workshop. But I can send that out again.
We can send that to everybody.
But yeah, we could do that.
And what does that say?
This is the NASA wavelength graphic doesn't lead to the graphic. You have a more specific link.
If you just click it, it just blows up bigger. But you'll have to go to the nasa.gov, and they changed the web page it was on from years ago when I started using it. So I just did the generic nasa.gov.
So if you click on the picture,
it makes it bigger.
It will expand the picture. But yeah,
they probably want the extra information they put behind it, because NASA has what's called NASA Wave or something, where they have a little ditty about all the different wavelengths.
So you're just going to have to go to the NASA website and type in waves, right, or something. NASA wavelength.
Oh yeah, put magnetic spectrum, and that'll pop up for sure.
So Gretchen, the question was asked: will the kit be sent to everyone who participates? So the kits were already sent out to all the people who we have funding from alumni that allow us to send it out to a certain number of teachers for each day. So we had yesterday, today, and tomorrow, and so the kits have already been sent out to those teachers. They had to pay like $25 or whatever for each kit. So I just want you to understand that those have already been sent out, but I can give you the supplies that were sent out in those kits if you want to go and find the stuff yourself. And I have all the links like where we ordered them from, either from Flynn or from.
Yeah. Should we put that on the bottom of these? Would that be helpful if we put? I don't think it's advertised as saying that we're not promoting these places, but this is where.
I don't care where we put it.
You think we can get away with that without getting in trouble?
You're going to go in and here's the thing: you can get the list. We'll talk about this afterwards.
Okay.
All right.
We'll figure it out. All right, but there you go. Someone put the actual link to that photo. Good. And the rope. Someone asked if the rope. If you're not doing the compression waves, you can do the S waves and do the wave thing with just a rope. I mean, I think actually I've used a broken extension cord with the ends cut off before, and so if you have an orange extension cord, you can use that. But that can tend to whip some people. Then we go into the different lights. Now, and here's where I'll have a question. Should I ask that now? Now, ask it now? Okay, I didn't know if I was getting too sidetracked. One of the things that, I mean, obviously we're doing a bunch of the, what do you call them? Help me out here.
Short.
Just 3 to 5 minute videos, kind of to go with that middle school degree even, but 3 to 5 minute videos that on particular content topic. So I guess let us know if it would be useful to you for us to do like a 3 to 5 minute video on each of the different types. And so we would talk about, ultraviolet light, what wavelengths does it fall under, what it can do, what can damage and what it can't, stuff like that. We can put those together if they're going to be useful. If y'all don't think that would be useful to you teaching, then we won't waste our time making them. But if you're like, yeah, those would be useful, we would use those in the classroom and have kids look at those or whatever, then we'll do it. But on ultraviolet, so yeah, okay, I saw a couple of yeses pop up. And so UV index, I found out last night, I put that in there. And so you put in your zip code and it'll pull up to tell you what the UV index is. And it's a nice reminder for students to wear not only a reminder, nice framework to talk about, well, UV light is very damaging to our skin. Sunscreen helps block or absorb that UV light so it doesn't penetrate the skin. And the amount of UV light that gets through the atmosphere will change. And so I kind of like that as a starting point, talking about UV. And of course, I always use the UV beads in the classroom. With the elementary, what I did was we did little bracelets, and they had like each of my students had like 3. We put them on just as bead bracelets, and I didn't tell them what it was, and we'd go outside for recess, and then they would change, and we'd be like, "Whoa, what's going on?" And we'd start a big investigation about what's happening. But then black lights, if you're just doing it as a demonstration, I still use the black light from when I was a kid on the wall. And we still use that black light, turn that black light on, which emits UV, and it'll make those beads glow. And that's really a nice demo if you're doing it as a demo. The invisible lights, one of the things we included in that kit, and we have several videos on, is the what's this called?
Prism glasses.
Yes, prism glasses. And these prism glasses are absolutely awesome. And they're just like, I don't know, we get them on like Amazon, and every year it seems like it's a different place. And we get like 100 for $20 or something like that. And then like a little, it's pretty close. Yeah, and so they don't call them, I don't know what they call them. They say don't stare at the sun. Well, yeah, don't stare at the sun with them. And don't wear them when you drive. Kind of see why. That was a camera. Let's see if they can see it. Now turn it. Yeah, it does a terrible job. Okay, but what Sarah does, what I like an activity that I've helped her with is she's doing for a slightly different purpose on the waves, but we have all the students have these on, and she will turn the lights down and light a candle, and it's the most thing that you can imagine. It's awesome. It's like, whoa. And you have them do, we did a video on it.
2020.
Okay. But she talks about the order. Explain that.
Yeah, the order of the wavelengths, that red is longer than violet. And that red corresponds, it's closer to the infrared side of the electromagnetic spectrum. And then, of course, violet is closer to ultraviolet. And because of the length, I have the kids kind of move their heads, and I say, well, can you ever move your head so that the red is near the source of the light, and so that you can flip flop it. And so with younger kids especially, they might try to, look at the thing upside down or move their head from left to right or move it. Every way that they move, every way that they look at that continuous spectrum, that rainbow next to where it's coming from the light, where they're bending the light, red is always farthest away from the source and violet is always closest to the source. And it's always that same order. That order doesn't change, and it's because of the wavelength in the continuous spectrum.
That's fun.
Mm-hmm.
Sorry, I got sidetracked. You were staring at the microphone as
Yeah.
you were talking, which is what he did in that chair yesterday. So I think it's the chair.
I think.
Well, I think it's the chair.
Yeah,
Right.
yeah. The glasses they work as a prism. They bend that light, and so yeah, they're working
Just like a regular
light
prism, yeah.
Just like a resin. Yeah.
Yep.
Yeah.
Yep. And they're cheap, and that's a fun way of teaching that.
Yeah.
Yeah, I know a lot of people use those CDs back in the day.
Oh yeah.
Oh yeah.
It
Yeah.
makes like little reflectors from those and stuff, but those prism glasses are awesome.
So the one question was asking, if someone out there has seen it, they've asked if they've ever found a cheap IR camera.
Yeah,
I
that's
have
where
not.
we're going next. No.
I have not found a cheap IR
The answer is
camera.
no, and they keep going up in price. Grab one of these. To show them what it was. But I tell you, I have a bunch of infrared pictures, and we can put the video together. It sounds like some people want them other different things, but I'm going to have infrared light have its own page, and I will put a bunch of different ones. Fire guns. Well, that's thermometer ones. That's temperature ones. The infrared guns. You got those for down to $20 even. But I did not see that. But we're going to do a page for infrared, and I have things like on that. I have where I walked across the wooden floor and took an infrared picture, and you could see my footprints. I have. We need to redo the van one because I don't know where that picture is.
I've got all those.
You have that? Okay, we'll put those up. Where he had someone on the inside of the van putting their hands on it and taking a picture of the infrared from the outside of the van. And then I have, it's like pipes. I took a picture of a chest freezer where you see where all the pipes in that chest freezer are inside it. And so we will put up all those. I will make this webpage and we can put those, and hopefully that'd be useful. But because, yeah, they're not cheap. We know that. But they're just little bitty things. And this is the iPad one. And so we just stick that on the iPad and download a program. And so they're fun. I mean, they're fun to use.
And they're called FLIR1.
This
FLIR.
brand, but you've got
Right.
others in the other programs.
We have the other ones too. I mean, they're all out there, and they're all about the same price.
Expensive.
So they're not cheap, but they're really cool. If you can get
You
one,
can put this right on a phone and use it.
I think one is plenty.
Yeah.
I can write
I don't
that
remember how much they cost.
All right in there.
There you go. But yeah, I just wanted to bring it so you could see what we use to make those. Now, something cheaper that all you students have is a cell phone. This picture here is one of my old remote controls that I keep in my Waves and Energy folder. And remote controls to take direct line. There are some remotes that don't use infrared light, but those are the ones you could use from the other room and things like that. I can't remember what wavelength those are. I guess it's radio wave. But these, most remote controls use infrared light. And a lot of cell phones, I find the Apple ones don't work because they have a filter that absorbs infrared light on them. But it's like your Android ones, those seem to work. Oh, yeah. We talk about visible light now. There you go. Yeah, you shake it one way, it turns it on, another way, it shut it off. But it's very convenient.
Okay.
But you shine it into that camera and you can visualize it. So what I'll do is shine the remote control and hit things around the classroom. I'm like, all right, everybody take out your phone and show your phone camera. And then I'll do it, and at least half the class will be able to see it. And the rest all flock to their phone, be able to see it. And then so we talk about, it's your big DSLRs, you can't see it through those. And some of your phones have actually a filter over the top that you can't see that absorbs infrared light and does not allow it to pass through. And then of course, the infrared thermometer, someone mentioned the guns. Yeah, infrared thermometers, and we'll talk more about those in a minute with one of the demos that we do. The AR cameras, a little pricey, TV remote are good. And then for the high school, I wouldn't use it in middle school myself, but if IR remote sensing, I guess it depends on what's going on with NASA in the world. Because sometimes, like the Mars launch and stuff, that'd be a good time to introduce remote sensing. Yes.
Rachel made a good comment, and I never knew. I mean, it makes sense. You might be able to rent IR cameras from places like Home Depot, because they probably have them to use for going in to look for heat loss.
Yeah, that's a big thing they use them for.
But so it may be where you can go and talk to them and say, look, this is a school. Could I borrow one for a day? They might let you do that.
I can see that. It's worth asking.
It's worth asking.
They have nice ones. They won't be the little ones.
No, they'll be real nice ones. Yeah.
And that is one of the uses of them is looking for heat loss, for heat and cooling.
Yeah.
For houses and stuff.
Oh, okay.
Yeah.
Oh well, there you go. Surrendered one.
Yeah.
I like that.
I do too. Good idea.
But then moving on to microwaves. Let's face it, cooking popcorn in microwaves is the easiest way to do that.
Video game controllers, IR. Some are.
I think some are, but not all of them.
Yeah, not
the
all
ones
of them.
that have to. A lot of them are. It depends on which platform and system you're on,
Right.
because they have different ones that use different wavelengths, the bands, and so it really, really depends on them. Now, radio waves. Radio waves. I know we always talk about putting on a radio, just using a radio and stuff, but that's kind of outdated, and kids don't know what radio is anymore. Some of them still know what walkie-talkies are, but they don't know what a cell phone is. And your cell phones operate in the radio wave bands. So I keep wanting to say bands because they answer radio.
Yeah.
Because everything we talk about the bands. But so the area, the section of the electromagnetic spectrum, the radio waves fall under, which those could be literally like the size of a football field. It can be the size of the planet, the length. Some of those are really long waves. But your cell phones operate in the radio wave band. You know how they talk about like 5G, it's a big thing. Well, it's just a different frequency within the radio, within the band of radio waves. That's just a higher operating frequency that they're doing. And so these different Gs and stuff, those are different frequencies that they run. And those radio waves are very packed. That's a very, very packed thing. And what was that?
A student used a walkie-talkie and said it was really cool. It's like texting with your voice.
That's funny.
It's so fun introducing things.
I had a student ask if they could only use an AM station on the radio in the morning, which I thought was really clever. I think they were joking, but I don't know.
I don't know.
I don't know.
That's funny.
Yeah, it was funny.
And a PM in the
There you
afternoon.
Well, what would the PM be?
Oh, not joking. Exactly. I don't think that were either. But and one thing I used to do years ago is I used a metal mesh I got from like Home Depot or somewhere to replace screens because we needed to. But and so we made a little Faraday cage out of that, and I would play a radio, then put it in the Faraday cage float around my mesh, and it would drown it out. And so that's kind of a neat little demo to do.
Because the waves can't get in.
Yeah, it goes around it. That's what Faraday cage is for. And so that's kind of fun.
Are there scramblers that can be used to disrupt cell phone use?
I would guess there are, but I don't know if there are or if they're legal. Either one.
I don't know about
There might be
legal.
legality issues with the FCC on that.
Because I know in the schools they
Okay.
can't block.
Yes, and not legal in the U.S.
Right. Okay. I agree.
I would say, because that would be something jamming a particular frequency.
Right.
which is-
And you're not allowed.
yeah, I totally understand
Yeah.
wanting one.
Right. Right. I
Yeah.
wanted one for my classroom, and it was again an FCC. We can't. block.
Now, microwaves, stealth technology that is like stealth jets use, they actually use microwave radiation to jam radar.
Oh.
Just saying. Well, I wouldn't want to just reiterate their waves.
Oh.
But all right, so radio waves. Then for assessment, what I love doing is having students do little projects. I know sometimes it takes time and it's harder for those in. but it could be as simple as a poster or create an infographic. I love having them do commercials, and it's to me, it's just fun. I like seeing their creativity.
Yeah.
And so it's simply, what type of wave are you picking or talking about? Tell us the wavelength, tell us the uses, and of course we could add to that. It's what are the benefits, drawbacks of this. Well,
Oh,
we'll leave that
interesting chat comment.
Yeah.
Now if people out there who are part of this are not listening or reading the chats, make sure you're doing that. There's a lot of information that you guys are sharing with each other that I'm not
You're not throwing it all out.
Yeah. But there's some good information, so just continue to read as you listen. All right.
The jammers are the FCC cannon will track you down. They will knock at your door, politely arrest you. And there's a huge fine for that. Now, anyway, and so waves and the energy brings us into seasons, right? It's probably good because it's understanding. And so the seasons, one of the things I love using is the radiometer.
Yeah.
Is the radiometer when I do seasons. And with this one, it's annoying that our bandwidth in this lab is so small.
It usually catches up.
It does, but it's not today. Oh, I need to fix that too. So, I don't have it playing on. I'll make it so it plays automatically small. But with this one, I actually set up 5 radiometers, and I put 3 of the veneer temperature probes in there. It's driving me nuts. Well, it's doing that. My other computer never does this, but this one seems to. Oh, there we go. It is catch up. And that is just one of the short things we put together showing the setup. And the first part we didn't see showed the light, and it's just an incandescent light bulb there in a thing. And then we show the temperature range. And now the interesting part, the one closest to the light is not spinning the fastest because it's not getting the direct light. The one in the middle is actually spinning the fastest, and you can see, we can pause. I'm not pausing fast enough. It doesn't matter if I pause if it's all okay. And you can see in that video that it is the warmest. The one getting direct light is warmest. So, and that's the screenshot from that. We can make it play small in here if that's more useful. But that is a setup that I would do every year in teaching seasons because it kind of drives home the direct versus indirect side of the idea. And I do the demo before, I didn't blow up the globe, before we do the globe and then I have the student hold a flashlight or just use the light up there. We kind of tilt, all right, what's 23 degrees? Let's tilt. Now we talk about this picture. We talk about that with a globe and a light source. Now this would get a direct light, where this is more indirect. This is graphic, slightly exaggerated, but it's the idea. And sometimes slightly exaggerated helps. But how we're getting direct versus indirect light. And so I think that does a good job with seasons. But then to talk about the weather and stuff, we want to bring in albedo. And that's, as we know, simply that how much things warm up, right? Is that we did this lesson. Yes. I'm going to kill the sound on that so it doesn't interrupt me. Now let's talk over it. But looks like a regular lamp, like the scale. You could use a regular lamp or a heat lamp. It's just whatever bulb you put in it. I always use an incandescent. Grab my lamp right there. That's what I usually use. I've used like desk lamps before with an incandescent bulb. have my little plant light.
Did you use grout thermometers with radiometers?
I did not set it up that way. You
Okay.
can,
Yeah, that's
but that's why we flew them. But see, I just use these. I have these everywhere, and I just put incandescent bulb. Actually, that's not incandescent because we use them to grow plants. It's just
But you just got these, I mean, you get these at any,
oh, they're cheap.
yeah, at Home Depot, Menards, I mean,
Oh, yeah,
and
for
they're,
$5.
these are real cheap.
And so yeah, those were very inexpensive, and I use those for everything. As you can see, that's my plant light here in the lab. But this video, we actually created it for the elementary kids STEM degree for the younger students, but it works so well to show exactly what we're doing. Is Sarah does the we do the these are drastically different. You know, like we set them down. 93 degrees. It was pulled out when we did this. Yeah, 42 degrees Fahrenheit versus 90 degrees Fahrenheit was the difference, just setting those in the sun on a chilly day. And apparently I was very amazed by the dumb look on my face. But that's, we do these, I would do these with my high school classes too. Just using infrared thermometers and the white cloth and black cloth with regular lights like that. And we did that also for seasons. And I used to use those big fluorescent halogen shop lights.
Oh, yeah.
And I had the small student thermometers, the junk ones we had at the school. And I would have students put those around to see what would happen when we talk about direct versus indirect, because those are so much heat coming off those things. And that was nice, but I melted a few thermometers. So I had these kids putting it like right in front of it on the grate, and they exploded.
oh my
They literally broke a few of those small thermometers. So, but I think those are so hard to find now because they're all LEDs now, which don't put off the heat that those buttons put off. So that gets us into albedo, and then a demo that I love. On this one, we don't need sound for it. Matter of fact, I'll shut off the sound. This, we turn on a green laser. It's a 100 watt, right? Green laser on this, on a white balloon. And in the kit, we included the Gatlin one. So because that's what my faculty member uses when he teaches this, because when he talks about albedo, he's one of my earth science faculty members, earth and planetary science. And so he does this demo in his lectures here at Purdue. And we're like, okay, that's cool.
Yeah.
And so I'm like, what one did you get? I wanted the same one you got. So, and that's what we have in the kit. We'll give you a link to these. Now, one thing, we'll explain. First, you can see we've left this on there for, about 30, 40 seconds so far. And it could have left it on there longer, but I'm not a patient person. So I finally shut it off. And then we switch out the balloon. And he used a little binder clip on a piece of wood just to hold it in place so it didn't blow around as much in the lecture rooms. And that was a great idea, especially since here we're right under those vents. It moved around quite a bit. And the little stand he has, he just took a 2x4 and he took a little saw and made a little U shape so it would just sit in there. Nothing fancy there. And you see almost instantly the black pops. And you jump a little bit at that because the white took so long just reflecting that energy where the black absorbed that energy, broke down the integrity of the balloon, and that balloon popped. And that was so cool. But now, these you can get anywhere. They work great. And also, if you're just doing the science inquiry, we used to use these for science inquiry. We put one on a table and tell students when they come in, they couldn't touch the table, but they had to figure out how to get that to move without touching the table. They would write down. We did a lot of science journaling in I think it was elementary workshops we were doing then. Mm-hmm. I can't remember, but we did a lot of the science journaling and kind of investigations and nature of science. So we would have them journal, write down ideas, then get together and write down ideas. It's a light bulb shape. Maybe it has to do with light. We're like, well, what do we need? What do we want to try? And we'd bring out flashlights and they'd shine flashlights on it to get it to move. and it's really, really fun. It's really, really cool to use those. Now, this particular laser pointer, it's I got it because it looked cool. Let's face it, but it's just 100 watt, right? 100 watt. This is 100 watt. Milliwatt, yeah, 100 milliwatt. Ooh, 100 watt, that'd be fun. But 100 milliwatt, sorry, green laser is all it is. But these, Bill, you want to explain the battery?
Yeah. So that do it this way.
It's not. It's just
There are two batteries. There are two batteries that you need for this, and they are
CR125C, right?
Sorry, I had it. I tried to email it to myself.
Well, he's looking it up.
It's so if you do Rayovac,
Okay.
Rayovac lithium is 123A, and I'll put that in there. But if you go anywhere else and you have this and they don't have the Rayovac 123As, they can move it to another number and they can find it. So if they don't have this, ask them what does that translate to for other batteries.
What we did.
Oh, yeah.
I always try to be rechargeable in our cameras and everything, and so I had found you could do. Is it not there? Don't worry about it.
Okay.
I had found a single rechargeable that would fit in these, and I bought it, and it was like I don't know, like $20 each for the battery. But then I found for like $25, I had 6 batteries and a flashlight. I'm like, obviously that's the deal I want to do. It wasn't. The flashlight was really fast, but the problem is I don't know what the problem was, why, but it wasn't as bright. We charged them up and they just weren't as bright. So Bill ran out and bought the regular batteries, and no more than we use these. I'm guessing won't have to buy them very often. There's that. And then when we do albedo, I always want to then pull up Google Earth. And so here's like, Lafayette, I think, as I say, I went to Lafayette, and I've got a zoomed out image, and then I got a close up image. And we can talk about how the different surfaces might, like the blue, the lighter ones are going to reflect more, darker is going to absorb. So then that gives us a thing to talk about, light and dark, the absorbance, and how that works. Didn't quite catch that. Some more information about batteries.
There you go.
Okay, Bill's on you there. And then we have, from there, albedo, we go into convection currents. Because now we have some places warming up faster than other places. So what happens with those hot spots, right? Well, this is basically we're introducing weather at this point. And we have the convection currents, lithium. The convection current demo. Now we have done this, oh my land, how many different ways?
Lots of different ways.
Yeah. This is the easiest. We use beakers because that's what we had here. We grab 2 jars, fill one up with boiling hot water, fill the other up with ice water, and set a clear tub on them. It's the simplest. I mean, sometimes you just got to keep it simple. And this was the simplest way of doing it. And this is actually like I have in our demos playlist the sped up version of this. It's less than a minute, where this is like the minute long one. And of course, it's on the playlist, so you can just play it too. But this shows perfectly, and this works. This has worked for us almost every time we do it.
Yeah.
Doing it this way. But the jars do have to be filled up all the way. Don't leave a big gap there, otherwise you have a little air insulation buffer. And so, but you can see how fast this is working. And you see that what do you call it? Blue. It's just like sitting there, not wanting to move. It doesn't have the energy, where that hot water has so much energy, and then it's just rising. So this is just, in my opinion, the best way for convection currents. And you can have this. You can do this in groups. You can have students do this. I mean, you can use mason jars if you don't have beakers in your lab. You use whatever. Those you can get from parents. Everybody has those in their basement. They love to give away those cheap generic ones. Finding the old ball ones can be called. But it used to be like jars for years. This demo goes on for a while. Like I said, this is the 4-minute one. And I like this one. I like doing this demo. And eventually the blue will start moving over and you can see it kind of starting on the edge, starting to rise up. And these are heats. We talked about convection currents, and that introduces all of our weather. Yeah, it's mesmerizing. The convection current one is just mesmerizing. That's the one time that all of my students are quiet for at least a minute. They're like, oh, they're not as, that's nice. And so it's peaceful. And so, but it's a fun demo. I'll have the students do those in groups. Some years, other years we just don't have time, and we just do it as a class demo. But there's that one. So we went ahead and set it up so either sign it to class, you can use it, or just gives you an idea one way of doing it. All right, so we talked about convection currents, but why do convection currents work? Well, it's their density, right? Because the warmer air mass is less dense than the cooler air mass is denser. And so one of my absolute favorite activities to teach is our density straws activity. Now with this one, I went ahead and made a little page out of it. We have taught this since I've been here, 20 years. We've done this probably close to 1,000 different times.
Easily.
And so we know densities, mass over volume. Oh, we have a white. Do we have a marker?
Yeah.
I want to do that real fast. My love. Or just grab a piece of paper and a marker.
Okay.
Regular marker. So then doing the density, I'll do that in a second. But the density, of course, I usually talk about convection currents, and I said the warmer air, why does it rise and stuff. Then with the tape square, that's one you used that in your class. Then you taped off the spot.
Yes.
You and Sarah used that one.
Yeah.
Explain that.
You just tape off a section in your classroom on the floor, and it's so easy to just go, okay, if I put in 5 kids in there, can you move around pretty easy? And they're like, yeah, this is pretty easy. And then, okay, what if I add 10 kids in there? And then what if I add 15? And then I always went like, okay, what if I add like 300 people in there? Well, then they're going to have to start stacking. And so they start talking about how it's going to get heavier and it's going to be, so it's such a visual for density, because then you pull them all out and you have one kid in there and you're like, okay, this is easy. I like it for the stack part, because eventually, like when you get to so many kids in there, eventually the next one has to go on the next level because there's no more room. And so that goes back to the density straws here in a minute, which I think is really nice to talk about.
And I used the square originally not for density, but I used it for heat. Talking about as things heat or cooler, they're more compact, and where it's warmer, they start spreading out more. Actually, I first used it for that, but I'm like, oh well, yeah, this is density too. And like both of you think independently of each other, like, oh yeah, we do this for density too. I'm like, yeah, okay. But the density straws is literally one of my favorite lessons. I had a friend who just retired. I would teach this in her class every year. And I started off teaching it like in the middle of the year. And then it's like after the first 7 years, she's like, no, I need you to teach this my very first lab. I want this to be my first lab. And I explained why in a second. The density straws, we did it. We do it. Once again, I do everything as simple as possible. I save gallon jugs, and I use 4 1-gallon jugs. And I have a 1/4 cup measuring scoop thrown in my stuff with salt. And so I usually put salt in. For when we did this little video, I put the salt in last, but that works. Usually I just dump the salt in, fill it up with water, shake it up, then put my food coloring in, and I'm done. Now I do, and I put here that I get my bottles of food coloring from GFS. If you just use, a few drops out of the thing, it's going to be really too light, and it's hard to distinguish some of the colors because it's too light. You have to use a little bit more food coloring to make it the intense colors that we like to see. But and then each group gets a cup of each color. And so now I've mixed this up in gallon jugs. It takes about 2 gallons per class usually, and I'll explain why. And I do these in groups, so I have 3 or 4 students in a group, depending on the size of the class. And so I'll have a gallon of yellow with like no salt in it, a gallon of, let's say, red with a 1/4 cup, 2 1/4 cups, 3 1/4 cups. Dump, easy, you don't have to think about it. And so then I'll have another cup where they can dump things in if they have extra. I call it the dump cup. But I don't tell them what to do or how to do it. I give them this stuff, and I'm like, all right, I need you to bring me a straw, no foreign objects, all four of these colors stacked, no air gaps between the colors, go. And they look at you, and I'm like, no, go. And, and so they work out, they figure it out. And straws are still popular. And this might be outdated here in a few years if it's all paper straws.
Yeah, they won't be able to see it.
Yeah. But so it might eventually be outdated. But it's because you have to use the clear straws. And I tell you what, if you forget them, I went to go to school once.
Yeah, keep going.
So that's battery stuff. And so, it's the food coloring. I have little vials that I use. Is probably 10 mil. Is it that big? Probably not.
Yeah, I don't think it'd be more than 10, probably between 5 and 10.
Yeah, maybe 5 mil. A bunch of them. It was like I don't even know where they came from. They were in the back of the lab. And I use those for density straws. I'm like I pre-fill them up, so I'm ready. And so I tell the students to go and find them stacked, and they'll eventually start figuring out ways of getting some. We'll get some in straw, then they'll try to dump it into one, and they'll work together all these different ways. And eventually, I didn't put that picture in here of the finished one. Oh, I'm sorry. We took those pictures too.
Yeah.
I'll update a picture of a finished one to show you what it looks like. But the whole straw won't be full, just the bottom. Because think about it, you have a cup. Your straw, your liquid can't be taller than this, so you can't put more than that in the cup. And you'll just take the straw and put your thumb on it, lower it just a little ways into the cup, go into the next cup, lower it a little bit more, take your thumb off, put it on. Slower is better, by the way. Kids can go really fast. Going slower is better. But I let them figure that out. This is something that they really figure out. And like I said, 1 gallon. Oh, a couple of tips. Don't put a light color with the no salt, being less dense, because that's the one that will get contaminated the easiest, like the yellow. If it's a lighter color, it contaminates easier. And so you don't want that is the one with none, because they just go through it too fast. And don't use the order of the rainbow. I was doing, the battery thing. I was,
You can
squirrel.
come on.
Leave me alone. But I was doing it. Actually, it's in here. It was her classroom that I did this. I was doing this. We were having our discussion. Now, why do they only stack in one order? Of course, it's density, right? And once we got to the fact, I'm like, all right, what's in it? Okay, well, I'll tell you what I put in it. All these are just food coloring, salt, and water. And I had a young lady, and she's like, oh my gosh, the rainbow is because salt's in it? And she was convinced. The rest of the class started laughing. I felt sorry for her, but it was hard to really keep a straight face at that point because she saw that there was a rainbow because there's salt there, and that's what caused the rainbow. So I avoid that so we don't foster misconceptions. And the other thing I do at lunch, switch the order up. Because after lunch, you'll have groups coming in. You'll always have that 1 or 2 kids every class after lunch. They've talked to their friends, even though you tell them not to. They've talked to their friends. They know exactly what to do. They walk in, I need to do it. They'll start doing it. The order doesn't work. And so they either think they got pumped by their friend or they'll spend a half hour trying to make it work because they were told it did and they trust them. And so I always change at lunch. And so you'll want to have, I usually have 8 to 12 gallon jugs. I make up all the mornings beforehand. You could make up the whole days beforehand. I usually spend lunch making up the afternoon ones. But after we do density straws, one thing I do. Okay. One thing I do is I'll go up to the whiteboard and I'll be like, all right, so what happened? And okay, well, there's more salt in ones than others, right? And sometimes kids will know they've heard of density. They'll say something about density, and other times they don't. And I'll be like, all right, I'm going to tell you guys what. This lesson is about my favorite thing in the world. It's all about density. Because density equals love. I don't know if that's focusing or not. But I put the little heart there just in case you can't say it, like density equals love. Don't you love density? And they'll be like,
yeah.
No.
No.
Some will say, yeah, brown nosers. Or I'd be like, no. And then they're confused because they got something that's just meant actually loved. So I'm like, you don't love density? It's terrible. This is terrible. We'll put a line, can't see anything on the paper. It is too. Yeah, it's D equals, then you put a heart. They can't see the paper. We don't have. All right, sorry. I failed you, Paul. Why is it not focusing? Here, you take that. Do the focus. Is that focusing? Yeah, hold that there. I see D equals heart, and I'll put that up where.
Can you kind of angle it?
Oh, I can see it now.
There you go.
Okay. Oh, that's what I said. Well, I make that, then beside that, I'll write the equation off to the side. I'll write D equals mass M over V. And then I'll just stand there and I will wait. And then some kids will finally go, oh, I get it. What's hilarious is the end of the class or later after class, the kids are like, I get that now. And so the delayed reactions are the most fun. But I just tell them it's all about love. Density's all about love. And we do that, and then they break my heart when they don't agree.
It's their girlfriend.
Yeah, it's their girlfriend.
Okay. So a couple questions were asked. So you want the yellow to have the most salt. You just want the yellow not to have the no salt.
Huh?
You want the yellow to have. You don't want the yellow to have no salt.
Wrong. You want it to have no salt.
That's the one that's going to be.
You want it least dense.
Okay, so we said it backwards.
Then you said it
I
backwards.
said it backwards?
Yes.
Well, like it's the first time I've said something backwards. Yeah, yellow is no salt. Don't put salt in yellow because you want it to be the least dense. Otherwise, every time they do an order, it goes through it. Every time. It'll go through it. That's just, when I put yellow and no salt, make it the least dense, I go through half the amount as others. And this is just from years of doing it. You go through half the amount. We do start, like I said, I start down going and doing it. And then some kids will just be terrible about contaminating. And so I'll stop class and all right, Bill, hold up your yellow. Like, that's not the yellow. That's not yellow. That's not yellow. This is the yellow. It has to be these 4 colors, not different colors. Because some kids try to make someone try to score in there. And I'm like, it has to be these 4 colors, not different colors. And so we'll talk about contamination. In fact, the things are getting contaminated. And which is a really good thing. Now we are not seeing a computer screen. Do you have one of the lasers? Oh!
All right, so these are the lasers. This laser.
Go up there.
Hi. This laser was the one from yesterday. It is a small laser, and it takes AAA batteries. This is the one that I said was a cat laser. Okay? They use it for cat toys. This is the laser from today. It is quite a bit different, and it's also quite a bit more expensive. This is the one that needs the Rayovac 123As.
Yeah, this is only 5 milliwatts. Probably not enough energy to pop the balloon. That's 100 milliwatts. So that's why we have the bigger ones so we can pop the balloon. All right.
Okay.
That took care
Good.
Right.
All right. Where are we? Oh, for the density. After we get through, we have our density discussion, and then I want to do just a quick, hey, how well did they understand? And so you see the pumice, you see the rock thing I have down here. That's just like I think it's a piece of basalt, a piece of pumice I have. And I've actually put them on the scale to check their mass, and they're within a couple of grams. So I'm like, all right, these two, they mass out the same. We put them on the scale, we get the same number, right? And so which one is, and I'll hold them out, which you can't see because I'm sharing. Show down.
Okay.
I'll hold them out, one in each hand, and say, which is more dense? Point to that. And then, because I'm like, remember, we're talking density is how heavy it is for its size. If it's heavier for its size, it's more dense. Which is heavier for its size? And of course, you have to pass around the pumice. They've usually not seen that. And so the smaller one, if they weigh the same temperature size, then I didn't put the other pictures in either. Oh, they're fuzzy. I need to retake I used tennis ball, containers, filled one with cotton, filled one with gravel. I'm like, which is heavy? They're the same volume, but which one's going to be heavier for its size or more dense? And that one they usually get. And so I step it up. I will grab 2 pieces of 2x4, and there'll be a small piece and a big piece. I'm like, this is the same board, but I've cut off a section of it. I'll hold them up. I'm like, which one is more dense? Now this is the one that they start debating on, because it's the same material, right? And so I'm like, all right. And so some of them will get it. The ones that understand the density, they will get that. And so they're the same density. And others, this is where they need a little scaffolding, which helps them really develop an understanding. Because then we're like, okay, this one weighs more, but it's also bigger, isn't it? If I took an 8-foot board, I cut 1 foot off, I have 7 feet. It weighs 7 times as much and is 7 times as long. And so the ratio will be the same of mass over volume. So remember, it's heavy for its size. And so that's our density. And so I don't know if I went down a rabbit hole on that one or not. Greenhouse, oh yeah, last one's greenhouse effect. And that's where I got, this is a part of I think it's the middle school KidSTEM degree.
Yep.
We had grad students, I'm going to move that. In grad students show, they did this is the one in the jars. And something that they didn't know when they came in the lab to record it, they gave you 2 empty jars. If you do this, put sand or soil in the bottom of the jar. That gives it heat, that lets something in there heat up. Mm-hmm. And so, because they were trying to do it with empty jars, they're like, we tried this and didn't have luck. I'm like, put some soil on the bottom, here you go. And they're like, oh, this works great. But they just used the light out of their office, and it worked great. What they did is they used 2 jars. One of them has saran wrap on it. The other has nothing. And pop that out. Let's unshare this.
Okay.
Yeah, that was good.
Oh,
It'll stop right there. No, not stop video.
Oh.
Okay. You take that away from me. Okay. Now, what we did in the kit, because I used like veneer, my grad students, when they did it, they put regular thermometers in there, then they pulled it out and read it. If that works, that's great. You have those already, use that. That is totally fine. I've done it using the veneer, putting them in it, but I thought, well, we didn't have enough money to buy like a couple of veneer ones to put in the kits this year, especially with that laser. And so, use a grill thermometer. I love these. I use these, not every week because I grill out all the time. But just use the grill thermometer. You can get these that do the 2 different ones. I guess one actually does 3, doesn't it? Get these that do the 2 different ones, put one in one jar, one in the other. Then they can see what the actual temperature is. And so that works just as well as the fancy one, and that was only $20. Then you can use it on the weekend to do your grilling. But beautiful, beautiful. So you don't have to be overly fancy. You can just look at this because it happens really pretty fast. And so you can see that temperature start to change pretty quickly on that to drive that. But that was the unit that we have. The videos, you want to do the spiel about of all that stuff. Or do we want to do questions?
I think we want to do questions first.
Okay.
Because then if people have,
we're
going to do questions first, because then if people were here yesterday,
they know about the other things.
We're going to talk about all the superheroes of science. We're going to talk about our website and all that. If people who were here yesterday want to get out so they don't have to listen to it again, then they have that option.
Got it. Yeah. So
let's go with questions right now. If you have questions about
if someone said they're pumice stone, they buy the pumice for like bathroom cleaning. I got mine at a garden rock place. I went down there and looked through their stuff, and they had a bunch of pieces of pumice. And I'm like, oh yeah, hey, I'm teaching, and this would be great. And they're like, oh, okay, you can have that. And so yeah, they gave me a couple, and it's huge. It's like this big. One of them, and the other's a little smaller. But you might even check landscaping stores like that if they have like a bunch of rocks and stuff. Because sometimes they'll have that in there.
The Rayovac battery again was
123.
123A.
All right, were there questions for clarification?
So we want questions, but Stephen also asked us earlier, if there's suggestions you have that you want put on that page,
Yeah,
that would be another thing you could add right now. If there's something you're like, man, I wish you had this on there,
that's true.
that would be also beneficial for us.
That's true. And we can do the video because several people said yes, and they wanted the videos, the short 3 to 5 minute videos. We'll do those, and we'll probably actually have those as part of the middle school STEM degree that Sarah's going to explain in a minute.
More about the activity that utilizes Google Earth.
Oh, I can expand that out. Yeah.
They want you to talk about.
Oh, talk more about it. Oh, I thought it write more about it.
Talk more about it.
Sorry. That came from, before I used Google Earth, I printed off aerial photos that we found from somewhere. I don't know where they came from. And I actually put those under a thermometer, or under a light. And we would measure the dark spot and light spot, and we could find a difference on those. And so you can find things. Are you going to have a video? Well, I'll answer this one first. Can you help me?
We can make it.
I'll quit looking at that.
Yeah.
I've already done a video for Density Strauss. I just haven't posted it. We'll edit it again. The Google Earth. I will have them pull up the Google Earth and just talk about, all right, where are light areas and where are dark areas? And we could pick anywhere on the planet to find light and dark areas. And then we can zoom in, and it goes so well with our weather unit. That goes so well with the weather unit because we can zoom in and we can see the regional. Some places get warmer than others. You can also talk about your island heat effect, your urban island heat effect, where the cities warm up because we have more of the darker things. That's where we have more heat in the atmosphere. And heck, they researched that, and scientists are researching that upstairs in Fort Fort now, where storms come up to a city, it has that extra heat, it builds intensity. So actually on the far side of these cities, that's where the storms are more intense. But I think I got distracted there. You're not surprised by now if you've been with me for an hour. The activity itself, we just have them pull up Google Earth, look at different areas, talk about what's lighter and what's darker. Now you can go into your anthropologic effects if you want there, because you can zoom in to see why an area is darker or why an area is lighter. You can go into that. You could go into, for that matter, you go into the poles. Patrick Taylor, one of the NASA scientists we collaborate with, he pulls it up to talk and he has animations looking at different times of the year to talk about the polar ice, how it's getting bigger and smaller.
And we had that video. We had that last year.
We do.
As part of our.
We need. Can we write that down to put that on here?
Yeah. So, sea ice melting from Patrick Taylor with the NASA animation.
Yeah, that's a NASA animation. That's a really good one. The list. Okay, we'll put that up. I should have. When I made those web pages, I just didn't think about it. But the sea ice.
We want more questions?
Yes.
Yeah.
Any ideas on explaining the role of gravity in ocean tides, the orbital motion of planets, their moons, and asteroids in the solar system?
That was a lot of different things in one long question.
Yeah. Any ideas on explaining the role of gravity in ocean tides? So
Gravity and
ocean tides, the orbital motion of planets, their moons, and asteroids.
now we have. I don't think it's the best fit for some of our standards, but we do have a lot of stuff from my planetary science group. We have a whole planetary science group on the EAPS Passport Day. I have a whole list of little videos they did. And some of them they don't talk about the asteroids. They talk about a lot about dwarf planets, the solar system some. But none of them talk about gravity on ocean tides yet. We could put that on the list.
Yeah, what's that? Gravity with ocean tides?
Yeah.
Orbital motion of planets.
Okay. I mean, that's one of the reasons Pluto's been not classified as a planet. because it's on orbit. Although it depends on that. That's just for astronomers. For our interviews that we do, we interviewed a planetary geologist, and she was calling the moon a planet. And so I asked her, well, you're calling the moon a planet? And she's like, well, yeah, it is, because it has plate tectonics, it has crust, it has all these things. And she's like, oh, well, you're referring to what the astronomers' classification system. We geologists don't care what they think.
So there were a lot of points that were important, but only spoken.
Okay.
Can you include these in the web page, and maybe in the future have all those on slides so it's easier to follow the presentation?
Yeah. Yeah, I could do that.
The other thing
It would be helpful.
The other thing we'll be doing, and this isn't helpful for you quickly, but this recording will be on that page as well.
Yeah.
So you can go back and re-watch and listen, but yeah, we understand what you're saying.
What else you got?
Can you start with gravity and just expand? So what they're talking about, gravity, the gravity question is one of the standards they cover in 8th grade. They're supposed to tie the concept of gravity to all those objects.
Okay. Now that's in the questions. I'll work on that this summer. Well, it'll probably be fall when my grad students come back. I'll have them help me do that. Yes, we'll have a link to the chat. See, this just shows us some plan.
Yeah. Maybe it's your fault. Yeah, you'll have like I said, we'll pull out especially with the chat, we'll pull out any stuff that's, I'll say, not relevant.
Hey, I have no idea how we need to interview someone on that. How do we know how animals see?
Okay.
Because I have no idea. I'm not a biologist. I always wondered that myself. How do you know that?
Yeah.
Because, they say some of them see in infrared, some see in UV or something.
Mm-hmm.
Like bees see in UV. And then some, yeah. So that's a good question.
Mm-hmm.
I have no idea.
The suggestion for magnetism.
Well, that would go well with the magnet, because electromagnetic energy is both electricity and magnetism, and they're just running opposite waves. Yeah, perpendicular waves.
And Michelle, thank you for your comment. We understand, and I think that's one of the callings that we have, is to help teachers with content that maybe they have been thrown into. We understand that standards have changed multiple years, and one year you're teaching this, and next year you're teaching something else. So,
and on that, who'd you say, with Michelle?
Yeah,
somebody.
Michelle.
If there are other things, if you're looking ahead, and you're like, man, I really need some help on that, let us know. Give us a holler. Give us a shout out. A video for the Straw Lab. We took some video clips of that actually yesterday, late afternoon, but I didn't have time to edit them. I will edit some of the videos for my introductions and how I do it, and I show how to do it. I will put that up on that web page. Won't be next week because I'm on vacation next week. If I don't get it done this week, then it'll be after next week.
I put the email back in there again, k12science@purdue.edu. That's an email you can send that will go to all of us. If you have questions, in that way, it'll get to the right person, or the person who has knowledge, or whoever grabs it.
Yeah. Mm-hmm. Okay.
Any other questions? And you can keep making comments, and that the more comments you give us, it's just firepower on our end. But I also want to respect people's times if they need to. And then we're going to start, if there's no more questions, we're going to start talking about.
We do want to explain the severe science side of things.
And no, the sound didn't go off.
Sound went off?
No, I said no, the sound didn't go off. We just all stopped talking.
That'd be a first. Yeah, we were reading points, slides.
Yeah.
So the points and slides one. So like make a slide presentation for this.
Well, yeah, that way they have a reference point going back.
Okay.
Because there was a lot of things said that weren't on the website.
Yeah, I'm really bad about that. Okay.
Yes, and last year's PD had a great lesson on magnets for the person looking for electromagnetism. You are correct. And we'll show that here in a minute, right? How to get back to those ones from last year.
Yes, yes, we'll show, yeah, because we've done a similar workshops for 3 years now. We just try to change up. And also, the recording through, we'll have the chat, yep. For lessons we're touching. And so with the lesson plans for lessons we're touching on, is that like the Google Earth one? Do you want me to break that down into a regular lesson plan? Is that what we're asking there? Those type of things?
I think that's
Okay. Yeah, I can write those out. I can. And that's the problem when you've been teaching it for so many years. You just kind of step in and do it, and you don't. So sometimes I forget that other people haven't done for years.
And last year.
We'll show you how to do last year's in a second. The Disney straw ones is that's such a fun one to do. Now I do tell the kids not to wear white that day because food coloring could stain.
Mm-hmm.
I just tell them we're doing a lab, make sure you're not wearing white, blah blah blah.
Thank you, Michelle. So for those of you who are bowing out, don't forget you need to send me an email with the last 4 of your social security number so that you can get the CRUs or whatever you call them in your state. My email is wbailey@purdue.edu. There it is again. So just send me an email, last 4 of your social security, and then I'll take care of getting you the certificate.
A quick reminder on this web page, we have all these virtual labs. I really like the ecology one. We have these ones from this week that we've done. We've turned each of them into a web page. And we have a bunch of these that will go up by the end of the summer. But the other thing people had asked about last year's
one. So I just put that, with the website that Steve was on, I just put that in the chat.
Good.
Okay, so I'm going to do this every time he changes to another one so they know. That's the one that gave you the link to all these professional development now and other virtual labs that are on there.
All right, so now I'm jumping over to the YouTube Superhero Science. And we have a podcast too. Feel free to subscribe to both. But please do subscribe to the Superhero Science. But the questions, of course, we have Science from the Experts. That's where we interview experts. Everybody needs to watch the How Fireworks Are Made this weekend if you've not watched it already. That's a fun one. Then our science demos, which we're going to talk more about here this afternoon at 1. About the science demos, how to incorporate some of these into your class, and how to do some of them and all that. But then, where were we going? I forgot. I forgot where we were going. There was a reason we went to this page.
So I put that link in there for Superheroes of Science. Yeah. Now you have that.
Oh, last year's, right?
But we wanted to show you where to get last year's professional development because somebody was asking about electromagnetism.
Okay, well, I'm going to go to playlist then. Playlist.
High school, middle school.
Did I pass it?
This is last year's.
Oh, here's last year's middle school 2021 playlist. See, here's all the different sessions. There's the experiments with magnetism that Phil's talking about, that David did. And here's the recorded sessions for those. Then here's the, last year we did pre-videos for people. Is there a list for last year? It's just this.
So last year, the videos of the labs were sent out ahead of time. And that way the teachers could do the labs before. And then when we met with them, like now, we were talking about, okay, how did the lab go? Did you have questions? Things like that. So that's why you see up above on that playlist are the labs that were sent out. And then down below is the actual recordings of the day that we were live.
Right.
Yeah. And on my investigations of earth science, I'm going to jump to that page really fast and scroll back up. The links I had at the top, see, are like 2020. These are things from the 2020, and this is from the 2021. I just didn't see a need to redo them. If we go back we have a playlist from the 2020 also. We make a playlist each year for these. Now in 2020, we estimated 3 playlists, one for 6th grade, one for 7th grade, one for 8th grade. Did I pass one? Okay.
There's our 2020 grade 8.
Yeah. And so here I'll view full playlist. And we can see there's a thing on the elements. Oh, here's the density straw activity. Hey, we did one on that already. I forgot.
I forgot.
Yeah.
I totally forgot.
Hey, and there's your cans of.
Oh, my tennis ball containers.
Right.
So apparently I did the video already. So I don't have to edit what we did last night. I'll put this in it. Wow, look back to your stuff, you realize you've done things.
Your hair's no different.
I didn't get to comb it today. I was in a hurry. Kind of late. Oh, that's a good point too, right there. I always walk away as students get that, start doing that, and make them come to me because they'll turn it.
Yeah.
Rita says you look good.
Aww. Hoping my hair wasn't too bad today. But so yeah, so apparently I've already done something on that 2 years ago and forgot. But the whole, you can see here where I used gallon jugs in all of that. So there we're actually mixing it up. So yeah, we got an extensive video on this already.
Yeah.
Who knew? Clearly not us.
Yeah. So it's in the 2020 playlist.
Yeah, that's in where we see here the 2020 playlist for what grade?
Grade 8.
Grade 8. And I will put this on lunch probably, a link to this on the density straws page that we showed earlier. Well, I didn't know we did all this already. I should look to see what we have before I make new things. Why did I quit talking? What else were we going to mention?
If we want to get to so today's lab page for the investigating.
I showed you one way to get to it, and that's going through the website. You just search Purdue Science, go to the college science page, and go to outreach, and then go for teachers. So that's one way. But another way, if you're more of a YouTuber.
If you're more comfortable with YouTube, or let's say you get exploring on YouTube and you think, or maybe you just remember Superheroes of Science and you think, wait, I know that they did some labs. How do I get to their virtual lab? Well, here's our landing page, and we're going to talk about science demos later this afternoon. We'll come back to Kids STEM degree, but the 4th playlist down, we have Science for Kids. And if we go clear to the end, you're going to see the high school and middle school labs. If we view full playlist, we'll get the link back to our site. And so that's going to circle it back to the outreach page that we started with at the beginning of today's PD. And then clicking each of these, the videos embedded in our virtual lessons will take you back to our channel. So we do our best to circle things so that you can get to our site, get back to the channel that you can hope we're working on, making it more, making it easier to find, easier to get those with fewer clicks. But also we're running our videos that we have in the virtual pages through our Superheroes of Science, because that's what we're using to show our impact for these things that we do. When we can show proof that we've been able to help teachers, that we've been able to have things that students can utilize, and we get those numbers for that, that's then what we can take as we continue to write our grants and show that we've been able to help this number of people.
Yes.
I think that's
So I have no problem asking you or begging you. I'll even get on my knees if I really, really need to. If you haven't subscribed to the Superheroes of Science, I don't know why you haven't, but please do. If we get over 2,000 subscribers, Stephen has to buy Sarah and I some stuff, and so we really want that to happen.
Yeah.